Hello everyone. We start with functions. What is a function? The function can be considered as a machine or as a computer program. So let's say we have a computer program or a machine. As you remember, we have some inputs and outputs. When we have a computer program, or we have some inputs and outputs when we have also a machine. Let's say the input is x in this case and the output is f of x. So this circle can be considered as a function f of x. So for each value of x we have f of x. Let's say y is equal to f of x. So in this part we will mention the formal definition of function, that is the mathematical definition of function. Then I will introduce domain and range notions. Then we will have some standard real functions like absolute value function, and then algebra of real functions, finally even and odd functions. Let me now mention about the formal definition of function. If A and B are two non-empty sets, then a rule which associates each element of A with a unique element of B is called a function from a set A to set B. If f is a function from a set A to a set B, we represent it by this notation. F is from A to B. If f associates each element of A to B, then we say that y is the image of the element x under the function or mapping, and in this case we write y equals f of x. What is real functions? Functions whose codomain is a subset of real number are called real functions. What is the domain and what is the range? You may remember all these concepts from high school, but I think it's a good idea to remind again. Again, f is from the set A to B. The set A is called the domain of the function, and the set B is the codomain. The set of the images of all the elements under the mapping or function, f is called the range of the function and represented by f of A. In this case, the set of range is denoted by f of A, which is f of x. Here x is from the set A. And don't forget that f of A, the set of f of A, is included by the codomain, which is the set B. Now consider a function from the set of natural numbers, that is n, from n to the set of natural numbers n. So f is from n to n, and consider the famous parabola x square. What is the domain and what is the range of x square? Domain is the set of natural numbers itself, as the function is defined for all values of n. X square is defined everywhere. This is why the domain is the real line, actually. Okay, but if f is defined from n to n, in this case the domain becomes n. The range, what about the range? For each value of x, for each natural numbers of x, we have some numbers. For instance, for 1 we have 1, for 2 we have 4, for 3 we have 9, 16, and so on. So this set is the range of the famous parabola x squared. And again, don't forget, f is from natural numbers to natural numbers. If you have f from real numbers to real numbers, then the domain will be the real numbers and the range will be the real numbers again. We have two more examples and we will find the domain of these two functions. Don't forget, if we have square root functions, we must focus on the inside of square root function. So the inside cannot be negative. The inside of square root cannot be a negative number. This is why we have 9 minus x squared is equal or greater than 0, or x squared minus 9 is equal or smaller than 0, okay, by simple calculation. Then if you factor x squared minus 9, that is, if you write x minus 3, x plus 3 instead of x squared minus 9, then you have this inequality. In the next step, x, you see that x is in between minus 3 and 3. So this is the domain of the function, the square root function. What about second example? If you have a rational function, be careful about denominator of rational function. Denominator cannot be 0. If the denominator is 0, then the rational function becomes undefined. So in which case the denominator is 0. X squared minus 3x plus 2 is equal to 0 implies x minus 1 times x minus 2 is equal to 0. So we have two cases. X is either 1 or 2. So if you subtract these 2 points from real line, then you have the domain of the given function. Another example, find the range of the following functions. We have two functions and we will find the range of them. Let's look at the first one. We have absolute value function, and as you see, we don't have any point that makes absolute value function undefined. So this is defined for each value of x. So the domain is real line. The domain of f is the real line or real numbers. What about the range? As you know, the absolute value function cannot be negative, or absolute value of x minus 3 is equal or greater than 0 for each x. Or you have these inequalities again for each x. This implies that your function f of x is equal or greater than 0, and it is bounded. It cannot be infinity. So the range is the closed interval 0 to infinity. If you have some inequalities for f of x, it means you find the range of the function. If you have some inequalities for x itself, then it means you find the domain of the function. What about second example? F of x equals 1 plus 3 cosine 2x. We start from a known information. What is a known information? We know that cosine function is in between 1 and minus 1. Also cosine 2x, cosine 3x, cosine 1 billion x it is also in between -1 and 1. So what about 3 times cosine 2x? Then you multiply each size of inequalities by 3 for each x. Then you have 1 plus 3 cosine 2x. Then you add 1 to each size of the inequalities. Finally, you see that f of x is in between -2 and 4. It means the range of f is the closed interval -2, 4. So the next part, I will introduce some standard real functions. So we start with the constant function. A constant function from real numbers to real numbers is defined as f of x equals c. Here c is a fixed real number. What does it mean, f of x equals c? What is the domain and range? The domain of f of x equals c is the real numbers. What does it mean? It means for each value of x, the function is defined. So the domain is the real line, the set of real lines, the set of real numbers. What about the range? For each x, you only have one fixed real number. For each value of x, we have only one fixed real number, which is c. It means the range of a constant function is the fixed real number itself. Second famous function is the identity function. A function from R to R is called identity function if f of x equals x for each value of x. What is the domain of identity function? Again, for each value of x, the function is defined. If you have this case, the domain is real numbers, the set of real numbers. And what is the range? For each value of x, you have x. So since the domain is the set of real numbers, the range is also the set of real numbers. For instance, for the value of 1 over 2, you have 1 over 2. So for each x, you have x. So the domain and the range is the same. The third famous function is modulus function or absolute value function. A function from R to R is called absolute value function or modulus function if f of x is minus x for negative numbers and f of x is x for 0 or positive numbers. What about the domain of modulus function? Since again the modulus function is defined for each x, domain is the set of real numbers. What about the range? Since for each x, for each real numbers x, the absolute value function or the modulus function cannot be negative, right? It cannot be negative. So the range is non-negative real numbers. Okay, let's look at this function again, modulus function. You should know the graph of this function also. As you see, for negative numbers you have minus x. For positive numbers you have x from 0 to infinity. Now let's look at an example of modulus function. Let's say this is y is equal to sine x. What about the graph? And we are familiar with the graph of sine x. What about the graph of modulus sine x? Since modulus function, in the modulus function we don't have negative numbers, so absolute sine x or modulus sine x, in the graph of this we don't have the lower part of the graph. then for this part you have the symmetry of this part above. Okay, since you don't have the negative values, you have the symmetry of this part, and so on. And the other famous basic function type, greatest integer function. A function from R to R is the integer function, and it is denoted by this parenthesis, and this is the greatest integer less than or equal to x. For instance, 2.4 is equal to 2, since this number is closer to 2, and minus 2.2 becomes minus 4. Okay, and I think you are familiar with the graph of greatest integer function. What about the algebra of real functions? Let's say the function f is defined from d1 to r, g is defined from d2 to r. Then the addition of these two functions is from d1 intersect d2 to r, and f plus g of x, of course, is equal to f of x plus g of x for each x which is in the intersection set of d1 and d2. We have the same thing for the subtraction also. If you multiply by a scalar, then you have this inequality, and they are very basic properties actually. And you have the same thing for the product of two functions, but be careful about the quotient of two functions, f over g. Again, f is from d1 to r, g is from d2 to r. Then the domain of f over g is the intersect of these two sets minus x numbers such that g of x is equal to 0. So be careful. If a point makes denominator 0, or if a point makes g of x 0, then you subtract this domain from this point from the domain of f over g. Composition of two functions. Again, the domain of f is from d1 to r, g is from d2 to r. Then g, the composition of g and f is from d1 to r, and g composition f of x becomes g of f of x, and range of f is included by domain of g. We have the same thing for the other case. Let's look at the example. Some examples. Let's say f is the famous exponential function e to the power x, and of course the domain of course this set is from r to positive real numbers, and g is the logarithm function here. Now we will find some values of f plus g, f times g, etc. f plus g of 1 is equal to f of 1 plus g of 1, and then finally using the given functions you can easily find these values. F times g of 1 means f of 1 times g of 1, and again it's easy to get 0. The third one, 3 f of 1 means 3 times f of 1, then you have 3. And f composition g of 1 means f of g of 1. First you find g of 1 from here. G of 1 is logarithm 1. Then f of logarithm 1 means you plug the number logarithm 1 in the function f, then you have e to the power 0. Since logarithm 1 is 0, you have e to the power 0, which is 1. Okay, you can easily solve the next question using the same idea. Okay, I think this example is also easy. I leave this problem. Well, and finally, I should mention about even and odd functions. Even if f of minus x is equal to f of x for each x, then this function is called even function. Even. If f of minus x is equal to minus f of x, then this function is called odd function. And cosine, since cosine minus x is equal to cosine x, this function is even. Since sine minus x is equal to minus sine x, sine function is odd. Okay? Now we will see some examples about even and odd functions. Now let's look at this example. Prove that x squared minus modulus of x is an even function. So the first step to find whether a function is even or odd, you have to write minus x instead of x, then check whether you have minus f of x or plus f of x. So for this example, we have, so I write minus x instead of x. Minus x square minus x. It means you have x square. So my modulus of minus x is modulus of x itself. Then what is this function? It is actually the given function f of x. Since f of minus x is equal to f of x, this function is an even function. Another example, we have a given function x cube minus kx squared plus 2x. X is from the set of real numbers. Find k such that f is an odd function. Again, we write minus x instead of x. Minus x cube minus kx square minus x square, of course. Okay, and minus 2x. Okay, after simple manipulations, calculations, you have this result or this. Okay, so what do we have actually? If k is 0, then the function becomes an odd function. Okay, if k is 0, the function becomes f of x cube plus 2x. If k is 0, the function becomes x cube plus 2x. In this case, the function is odd. If k is not 0, then the function is not an odd function. This is the end of this lecture. I will talk about functions in the next video.